Hello everyone. In this presentation, we are going to study three important algorithm design techniques: the greedy method, graph algorithms, and tree algorithms. Algorithms are step-by-step procedures used to solve computational problems efficiently. These techniques helps us design solutions that are faster, simpler, and more effective. The greedy method focuses on making the best decision at each step. Graph algorithms are used to solve problems involving networks and connections. Tree algorithms are used to process hierarchical data structures. These concepts are very important for exams, interviews, and real world applications. The next, greedy methods basic ideas. The greedy method is an algorithm approach where we make the best possible decision at the current step without thinking about future steps. At every stage, the algorithm selects the option that looks most beneficial at the moment. Once a decision is made, it is never changed later. Because of this behavior, greedy algorithms are very fast and easy to implement. However, it is important to remember that greedy algorithms do not always give the optimal solution for all problems. They work only for specific problems where local optimal choices lead to a global optimal solutions. The next, properties of greedy algorithms. For a problem to be solved using greedy method, it must satisfy two important properties. The first property is the greedy choice property. This means that a globally optimal solution can be obtained by choosing the best option at each step. The second property is optimal substructure. This means that the optimal solution of a problem contains optimal solution to smaller subproblems. Greedy algorithms do not use backtracking or reconsider previous choices, which reduces complexity and execution time. This is why greedy algorithms are efficient and widely used. The next thing, applications of greedy method. The greedy method is applied in many real world problems. In the fractional knapsack problem, items are selected based on the highest profit to weight ratio. In the activity selection problem, activities are chosen based on the earliest finishing time to maximize the number of activities. Huffman coding uses a greedy approach to generate optimal prefix codes for data compression. Prim's and Kruskal's algorithms apply greedy principles to find minimum spanning trees in graphs. These applications show how greedy algorithms provide simple and efficient solutions. The next thing, graph algorithms introduction. So, what is graph? Graph is a data structure that consists of vertices and edges. Vertices represent objects and edges represent connection between those objects. Graph can be directed or undirected depending on whether the connections have directions. They can also be weighted or unweighted based on whether the edges have associated cost. Graph algorithms are used to solve problems related to networks, routing, communication systems, social media, and transportation systems. The next, graph traversal algorithms. The first one, graph traversal means visiting all the vertices of graph in a systematic way. There are two main traversal techniques: breadth first search and depth first search. Breadth first search explores the graph level by level and uses a queue data structure. It is commonly used to find the shortest path in unweighted graphs. Depth first search explores a path completely before backtracking and uses a stack or recursion. Depth first search is useful for cycle detection, connectivity checking, and topological sorting. The next thing, shortest path and MST algorithms. Shortest path algorithms are used to find the minimum distance between nodes in a graph. Dijikra's algorithm finds the shortest path from a single source to all other vertices provided there are no negative edge weights. Bellman-Ford algorithm also find shortest path but can handle negative weights. Minimum spanning tree algorithms connect all vertices with the minimum total edge cost. Prim's algorithms grows the tree by selecting the minimum edge connector to the visited nodes. Kruskal's algorithm selects edge in increasing order of weight while avoiding cycles. The next, tree algorithms. What is tree? Tree is a hierarchical data structure that represents parent-child relationship. It has a single root node and every node is connected by exactly one path. Trees do not contain cycles, which makes traversal and searching efficient. Trees are used in file system, databases, compilers, expression evaluation and artificial intelligence. Because of their structured nature, tree algorithms are simple and powerful. The next one, tree traversal algorithms. Tree traversal refers to the process of visiting all nodes in a tree in a specific order. In-order traversal visits the left subtree, then the root, and finally the right subtree. Pre-order traversal visits the root first, followed by the left and right subtrees. Post-order traversal visits the root after visiting both subtrees. Level order traversal visits nodes level by level using a queue. Each traversal method has its own practical applications. The next, conclusions. So, to conclude, greedy method provides fast and simple solutions by making local decisions. Graph algorithms are essential for solving network and connectivity problems. Tree algorithms efficiently handle hierarchical data structures. These algorithmic techniques are fundamental in computer science and are widely used in real-world systems. Understanding these concepts helps in exam preparation, software development, and problem solving. Thank you all, and we will see in the next video.